and kind of motivation to get, if you haven't really, you know, been working on your projects, and any motivation to get that stuff done now while you have the time, it's that we are quite literally in the middle of January right now, and a full design document will be due somewhere in the middle of March. This design document will have to have outlines for like full design documents completed, detailed component lists, any dimensions, the way that your stuff should function, any like detailed parameters, you know, target parameters that certain things should be functioning at. For example, will have to be included in this document. You know, testing procedures, detailed testing procedures, how you're going to make sure your designs are safe and stuff like that. Will you know, how you're going to make sure they're working on the day for the Hyperloop, and how you're going to like plan to make sure, how you're going to test your designs to make sure that they're functioning the way they are for the European Hyperloop Week, all inside this document. And unfortunately, this document falls right around the region where between midterm season and exam season. And I know you guys are, if you're on this team, you're probably also, you know, very academically inclined. You want to put in the time to do well in your midterms. You want to put in the time to do well in your group projects. And you need to be able to find a balance between that and the team. And unfortunately, you know, sometimes you'll have to pick one, and, you know, absolutely you want to focus on school. And so this is this critical region right here between this and once midterm season starts, that really a lot of this work should get done in this time. And, you know, if you're stuck somewhere, any time of the day, whenever you're working on something, don't be afraid to reach out to any one of us, whoever you want to reach out to, and just ask for help. You know, it's not a sign of weakness that you're asking for help. You're showing that you really want to get whatever it is you're working on done, and you want to do it to the best of your capabilities. Next week, we will go over a plan that we would have developed in order to get the pod manufactured and tested. And what is it? I guess the core part of that would mean the you guys will see that next week. But in the meantime, you know, keep this in the back of your mind. Really, you only have until mid-February if you're gonna start. If you're gonna want to have time to study for exams during midterm season, to work on this and make sure you get a finished product out.
Sorry, Anaki.
Yeah.
I have like a suggestion. Can we be provided with a template for the final design document so that we can start early as we go, and it's more clear, and we all have kind of the same flow through the document in the end. You know what I'm saying? Like a certain template that we can follow as
you'd like to include. Okay, yeah, I can provide that. And I think really it depends for the sub team, but I'll give the same template that I gave for my team. I don't know if you had a chance to look at the energy systems one, but I gave them a template. I know that like for electronics, for example, you guys have like the one with the electronics and software kind of combined, and it kind of follows a different style. I don't know if the energy systems one would be appropriate to use for that, like if it would like translate well. But if you want, I'll give it to you.
I mean, more as in a general organization sense, you know, like we first talk about the components, then we do the testing, the results, the target parametrics or whatever. So like the flow of the document, you know what I'm saying?
I see.
What the sections are laid out in a uniform way through all the teams.
I see. So like, you know, that order that you just spelled out, but for each sub team, I guess.
Okay.
Is that what you mean?
Yeah.
I just want.
Yeah, something like that. That's what I'm saying. Like something that, let's say, energy systems has this flow. It's not necessarily the same thing as we're designing and talking about different things, but we all have the same organization within a document. We talk about the subsystems within the subsystem, then we describe the components, how they work, what the testing is. You know, like we all basically what I'm trying to say is that we create a template for all the teams so that we can have the same flow through the document.
Okay. Yeah.
So when you read about the energy systems and you go to the electronics, you don't have like a totally different style.
Yeah. That would be good too for understandability and making sure that they really understand what we're talking about.
Yeah. Thank you.
Yeah.
Yeah,
Oh.
I agree with that as well. Like, we would like to make the document more continuous, so it's a lot more integrated and it's very easy to understand how everything connects together. Even though we have different sub teams, we should try going for that. But in terms of the timeline, yeah, like, we're doing, we're still planning some of these things out. But as I understand, the integration should start like relatively soon. And of course, we understand you guys have midterms. So we're actually going to start making some sort of a spreadsheet to account for these. So if you know like what times you have midterms, like try figuring them out if you don't know them. But that, and then sometime next week, we'll be sending out like a form that you guys could fill out so then we can figure out like when each person is busy so we can account for that when planning.
All right.
That sounds like a good plan.
January 16, 2020. Okay. We've only been back for a week, so I don't know how many updates there would be. I don't know how many of you guys really worked on this over the break.
So in terms of electronics, we don't have a lot. We started testing some of the sensors. Some of them we already know, we know how to use. Some of them are in progress. Yeah, a lot of it's in the early stages of getting back together.
Okay.
Yeah, we're hoping that so we tested one sensor, which is a temperature sensor, which is also available from someone in downtown. So if software is interested, they can start gathering up all the resources they need, and they can start testing out like their communication with system and their control system. And we can give them like the code to use each sensor and the circuit that's required for it, and then all they need to do is just start testing it and do whatever they need to do.
And you said the other day that some of the like I guess sensors you're like done with testing and you can hand them over already.
Exactly. Those are the ones that I'm referring to right now. So the ones that are easily like you can get them easily are the ones in downtown, which for the time being is only going to be the temperature sensor, the ProSense temperature sensor. And I think like we should be getting the Ethernet shield soon. I need to talk to Artin about that. But
Okay.
once this gets to MIE, like that's also going to be downtown, so Dave can just go and pick that up. And then like they have basically everything.
So to be bought. Arden, you like purchased it like through his link directly, right?
Yeah, waiting for it to be shipped.
Okay, waiting for shipping. I guess we'll move. Oris, do you have anything to say on the PCB side of things?
Yes, so the past week we got the Altium licenses. We decided to move to Altium because it's like we've been said that it's a better software in terms of design and also based on our experience it's pretty good. And
Okay.
this week we should be done with the schematics, and then we'll be using and the next week after this one we'll be continuing with the physical layout of the PCB. And
So
then
You guys are kind of like you're almost done with your circuit designs and you're moving towards like mechanically how it's going to fit together.
Yeah, something like that. Like the yeah.
Okay.
Yeah, and based on a rough timeline that me and Ermil did, we should probably like be ordering the PCBs by the start of February, and yeah.
So where did you guys learn to do the PCB stuff? Is there I know you talked to Puneet.
Yeah, so Colin provided us with some. I mean, it's a link which Colin shared with us in the Altium page, and that was really useful because it you know, and it depends on the person. There are also videos which teach you how to use Altium Designer for PCBs. But if you're a person that sort of likes reading better than just watching a video, like in my case, I feel that's better. We also have a link for that, and it's a really good link that takes you from the beginning to the very last stage of PCB design, and we can share that with you if you're interested.
Yeah, do you think you could share that with me? Because I'm kind of on that stage too, where I've kind of figured out what the schematics are. I guess I'll write that here.
Okay.
I
Yeah, let me
completed
just do it right now so that I don't forget later.
For HE control system. So actually I switched I don't know if you guys are familiar with the design, but I switched from a relay to a MOSFET combination, and that was thanks to help from Orist. There's actually a like bi-directional switch being used, and that will be controlled by the Arduino. And it's a lot smaller. It's a lot safer to use than using the relay. Switch thing.
So I sent you the documentation. There's just one point. The link will redirect you to a web page that says it's for version 18.1. Now, if you look in the top right corner of that web page, you can actually change the version of the Altium Designer software. And I don't know, do you guys have the licenses or no?
We don't.
Okay, so you can apply through Altium's website, and you can get student licenses, which last, I think it depends, 3 to 6 months. Ours, I think it's 6 months. Ours will expire in June, I think.
Do you guys have your PCBs? Okay, I actually know we'll talk about this later because I don't think it's super important for this part right now. But you guys are collaborating with Max on, you know, where the screw holes on the PCBs are, how you're gonna like fix those onto the pod.
Not right now, but we will be when we will be designing the physical layout of the board. Right now we're doing the schematic stuff. Later on, I think.
Okay. So you're gonna do it from like a schematic and then to the PCB.
Yeah, the first part would be to do the schematic and then go to like the routing on the stuff.
At the end of the day, worst case scenario, we can move the PCBs to different areas of the pod and just use longer cables. So that isn't too much of a concern. In terms of the mount, some like PCBs usually just use standoffs. So even that, as long as you can like drill in a standoff, you're fine.
Yeah, it's just like, you know, drilling the standoffs into the metal might be difficult when they're small holes because the metal's so thick.
Oh.
To tap
Yeah.
tap the hole.
Mm-hmm.
And a lot of the surfaces, and I experienced this problem, like a lot of the surfaces on the pod are like there's like another piece of metal right below it, so you can't use bolts and you have to tap a thread into the metal, and it's not a fun time. So ideally we have if it's already water jet cut for that spec, or Yeah, or something like that.
Okay.
Okay, we should talk about
Yeah, is Max on this call by any chance?
I don't see him. Oh wait, he is here. Is that him? Yes, that's him.
Okay.
Can you hear me?
Yeah.
Yeah, we can hear you, yeah.
Okay. Before I was trying to speak, but I guess my microphone doesn't work on my earbuds. I was going to say for the water jetting, I know I planned, or I made a note for the beginning of this month to catch back up with the mech team, or the mechanical team, to see when they have that scheduled, because I know that got pushed out, but they didn't really know exactly when, and they said to check back in around this time. So I can check in on that and then let you guys know what that deadline is, if that's what we want to go forward with, of like water jetting.
I think, yeah, like whatever works. We'd like to push it back if possible, but like if because these startups are like, they're really tiny.
Mm-hmm.
So yeah, like I think that we might have to go through with water jetting.
Okay, I'll check in on that. The other thing too, I guess, and I don't know if Sasha, if you would have talked at all about this, if there's like an actual deadline to when these things need to be done, like when everything needs to be mounted.
That's somewhat in progress right now.
Okay.
We're planning on like having like a final or like relatively final deadline and like timeline available by next Saturday.
Okay.
And we'll probably be announcing it like in this meeting.
Mm-hmm.
Kiki, Orst, and I, as well as Dave, we're gonna have a meeting sometime like next week about that.
Okay, sounds good. In the meantime, I'll figure out what's going on with the water jetting and what we can do.
Yeah, I don't think it's so much the water jetting, but I guess the placement. I know some of where we wanted to put the PCBs. There's like a giant, just a really big the bars for that the infrastructure team use there, and so you wouldn't be able to put the nuts underneath those.
Yeah.
And so you'd have to tap a thread for the standoffs.
Yeah. So I actually, if you guys are able to share the exact location, because the last time that we would have had a call to figure out the locations of all the mounts, we weren't too sure about the PCB's location yet. If I can get that, I can also talk to the mechanical team, see what they think as well, if there are other options besides water jetting.
Horst, Colin, Chloe, do you guys have locations in mind? If so, then I'll send them to Max, and then he can talk to the mech team about it.
Okay, we'll double check it and let Max know.
All right, perfect.
All right. I guess Dave, are you here? Oh yeah, you are there. Yeah, if you want to give some updates on what the software team is working on.
Well, actually, we actually met up today, so today was our first meeting. So for each sub team, we just went over what the last thing that we were doing. So the infrastructure team, they're working more on the front end, the back end. They did a little short demo for the front end, so it seems to be going well. With the controls and communications, the progress has been the same since last semester. So communications, they have just come up with like a general design for how we want these Arduinos to communicate and send data to the control system. And then the control system, we do have a general state machine that sort of works, sort of because we need the hardware to test it. I know you guys saying you have the temperature sensor available, so yeah, so whoever has it and whenever you guys are free, let me know and I'll just pass by to pick it up. With Matt, the last lead, I will be picking up everything from him on Monday. So whatever hardware that he has, I will get all of it on Monday. And Ermel, I think you mentioned someone in downtown has a sensor. So whenever that person's ready, just let me know and I'll pass by.
So that person is Colin. Colin, if you could reach out to Devendra about that, and then just give him like everything that you have, as well as with like all the circuit diagrams and everything else that he would need to get it working.
Okay. What about the pressure sensors though?
I'll be taking over that because there's just no way for you to test it because of the adapter connection that's on the sensor.
Yeah. Okay.
Yeah.
Yeah. So whatever you guys have working, I'll just pick it up.
Cool.
And
Yeah,
sorry, did you want to go, Ermal?
yeah, Colin, give him the pressure sensor as well.
Okay, I'll just give him the whole box.
Yeah, just give him like everything I gave you, basically.
Okay.
Yeah.
Oh, you said that you have the code. So is that available? Is that on the GitHub, or you guys going to send me it up?
It'll be on GitHub soon.
Okay.
Okay. For Devendra, your control system team, are they aware of the different
Inverter.
types of state machines like that the inverter uses? Like it has a few different like subsets of state machines that do they know that?
They don't. I know that, but they don't specifically know us yet. I gave them the document to read up on the inverter this semester, where we want to actually get started on that. But yeah, we're working on that right now.
Yeah.
But so far, yeah.
Sorry, go. You go.
Yeah, no, I was saying that so far we just wanted to make sure that we have a general state machine that works first. So now that we got that down, we can finally move on to the inverter.
Okay. Yeah, because I think so. I don't know if you guys read this section here or who wrote it, but Ormel really, there's a lot of stuff that was written and documented here that I think I know if you actually read the documentation for the inverter, it might seem like it's a copy paste, but there is a lot of stuff that was translated. Like okay, here, so tabulation. You will still want to look at the section in the inverter, but these subsections, and this is almost basically pseudocode on like how the inverter will transition to different states.
Right.
And it's located at the very bottom under AE5 for the electronic system.
Right.
Of the final intent to demonstrate document.
Mm-hmm.
Okay, so I'll zoom in here a little bit. But you can see the startup sequence for the inverter, and I think it's really important to make sure that the software side of things gets really melds together with the energy system side on making sure the startup sequence works, because it needs to like, initiate the pre-charge circuit, and then it needs to check for a bunch of things. I think the inverter does it automatically, but just knowing what state the inverter is in and making sure we're not giving it commands and stuff that it can't really be doing at that time.
Right. So we have a as part of the state machine, we have a state where a startup state. So I assume we'll be sending the appropriate signals to the inverter. So that will be a separate state machine for the inverter to just initialize, whatever it has to like recharge, wait, ready, and then if it's ready, it should send back a signal to us to move on to another state, and then when we're ready to drive, we should send something else. So we already have states to give the inverter some signals. We just need to know what to send and where to send it.
Okay.
But yeah, thanks. I'll definitely be looking at this one.
Yeah, because I wanted to build some sort of table, because there's actually like one, and then there's another table here, two tables that they're kind of they exist at the same time. They're different machine states. Yeah.
So whenever we have our meetings just with us, I'll have the state machine, and we can just come up with like a simple ASML algorithmic state machine to show like the steps that will just happen as the pod comes on, and of course when it goes off. So maybe that'll make things clearer.
Yeah, that'll be good. And I think So one of the big questions to ask is the inverter, or at least on our state machine, we have like a start sequence.
Right.
So for breaking, and I don't know what your conditions exactly for like startup is, because I know we don't want to activate this. Like the last thing that we're going to activate before we actually like start moving the pod would be the pre-charge circuit.
Right. So in the startup phase of the state machine, we will want to pre-charge the circuit for the inverter, and we want to ensure that the brakes and other subsystems are working properly. And only when we are ready to move, then we will send a signal to run the motor.
Okay.
So I see that there's a wait state and a ready state. So clearly, while the pod is on standby, it has to be self-looping on a ready state or wait state there. And only when we send the appropriate signal, then we'll have the motor running.
Okay, that's good, because that like wait state would probably control that like self-looping start state would probably control your the braking system. And I think the way that the braking team have it set up, correct me if I'm wrong, or is it's like it's a fail off. Like if the solenoid valve has no power, the brakes will be activated. Is that correct?
Yes.
So if for whatever reason, so that means before that, and the way that they brake is using this tank, this pressurized tank. So that means when they install that tank into the braking system, there must already be power on the pod. The low voltage battery system should...
You don't need that. There's a valve to turn
they have
it
a
on and
valve?
off. Yeah, they thought
Okay.
about that. They're not that primitive.
Okay.
It's a mechanical system, so I think it's right, or else I think it's a mechanical system, so it adjusts for itself.
In terms, what part do you mean?
The regulating the pressure in the
Yes, that part is mechanical. So there is a high pressure tank which is connected through a pressure regulator to the brakes, and what it does is when you keep the solenoid valve powered, the pressure flows from the tank to the brakes, which means that the brakes are open. And when the power is off on the solenoid valve, then the pressure leaks out and the brakes lose pressure and they close. So that in the worst case scenario, when the power is off, the brakes would close.
Yeah, so we can the last thing we were talking about with the inverter meeting is that we can take those measurements of power, so we can predict on the front end whether the brakes is on or off. That's something that we can do if we have measurements. Just get those readings, and that's it.
Yeah, the pressure readings.
Yeah.
Okay, that's good to hear. So I think that's just like another piece of integrations that, like, once we open that valve for the thing, that the low voltage battery is already powered. It's already installed.
Yep, exactly. So it would be fill up the tank. It would be close the valve so there's no pressure leakage. Fill up the tank, and then turn on the pod, and then open that valve. And then once the pod is on, like the pod would be controlling the solenoid valve, so everything's fine.
Mm-hmm. Because the low voltage battery can be like taken out, and then there's also just gonna be like a switch on there to make. Actually, the low voltage battery I might not even put a switch, but the high voltage battery I will put a switch. But it will. You can take it out and put it back in, and so at least when we're starting up the pod, we make sure that we install that first, and that it's not there isn't any loss of power from that point onwards. While we're doing all these other things.
Question, if we have time. So let's say in an instance where there's a loss of power or some critical function, just goes wrong, and the state machine comes to the decision that the pod has to stop. So how do we control the brakes? So how do we indicate for the brakes to come to a complete stop? Is there any mechanism for that?
Yes, there is a. Ormel, do you want to explain that, or do you want me to?
Go ahead.
Yeah, so there is so one of the Arduinos controls the solenoid valve. There is like a MOSFET switch there that controls
Okay.
the solenoid valve. So you tell Arduino basically to stop, to flip the switch or to stop the power going through the solenoid valve.
Okay, is that the same Arduino that we will be getting as well, or is that separate? Because I know Energy Systems has separate Arduinos that they use.
Software won't interact with any energy system Arduinos. So the Arduinos you're getting are the exact same Arduinos that will be used on the pod. The one you're
Okay.
going to get from Colin, that's only for testing. So you can like mess around with it. It's okay. The Arduino Duos, please be careful with those. Those are for the actual pod.
Right.
Yeah, so just to be clear, the Energy Systems Arduino, it will be one Arduino from there will interface with one of the Arduinos from electronics, and it will probably using I2C.
Okay. So I assume that will be your master Arduino.
It will be the master Arduino, and you can just tell it like I want the battery on or I want the battery off.
Okay.
And it can transmit like temperature information. It'll probably just send like the maximum temperature that it's reading.
Whatever we can get.
Yeah. But that you guys shouldn't have to worry about making that work. I have actually one of my members working on it, Natasha, designing that.
Okay.
All right. Just I guess Ormil and I talked. I know we're going a little bit over time. This meeting should normally be 7 minutes, but just like Ormil and I talked about this, a little bit of motivation. Sometimes you don't always. We're gonna show you guys some of the things. I'm gonna show you something I've worked on that I, failed at in the sense that I didn't. It wasn't. It did not turn out as well as I wanted it to, and then I spent a long time trying to redesign it. Actually, should I show it this one?
You've already kind of started it.
I guess I have. Actually, wait. I'm gonna switch to my iPad to show it. Ormel, if you want to show something too, like go ahead, or Dave or Orist.
Yeah. Let me find something. I don't usually keep my failures in front of my eyes all the time, so I'll have to find it. But yeah, I can show you something for sure.
I wanted to say something. Oh, my camera's off. Just I sent the message in the chat just saying that I'll be stepping away to focus on school and watching this meeting. It seems like Kiki and Irma will like have it under wraps, so I'm pretty psyched and I'm excited where the team's gonna go. And yeah, reach out anytime if you have questions or just want to chat or yeah, I'm still here. I won't be leading the electronics team, so, or electrical. Yeah.
Okay.
You'll be like the Yoda of the electrical team.
Yeah.
You will be. Okay, guys, I'll be back in a bit with what I gotta show. I just realized something I messed up on earlier today.
Maybe the Obi-Wan ghost, appears on occasion. Yeah. Yeah, but seriously.
That's fine.
Yeah. The force is strong. But yeah, reach out anytime, and yeah, I wish the team best of luck over the coming months. I think it's going to come together. It's kind of sad not to see it go all the way, but yeah, I'll still be around.
Okay, so hope I'm not interrupting, but so this is a pressure sensor that I gave to Colin. If you see here, there's like there's a riveting system here where you screw in like the connector. The way I assumed it works is that it measures pressure above like just absolute pressure. That's not how it works. So that's why Colin wasn't able to use it and test it and figure it out. And this is where I come in. Now he wasn't able to use it because it measures pressure above the atmospheric pressure. So if you measure it in open air, it gives you zero pressure, but if you measure it connected to like a pressure line, it'll tell you like whatever it is. So that's an issue here because you need to figure out some place you can get pressure. It turns out I have an air compressor, but the thing is I can't use this connector on the air compressor. I need to use like a different connector. So then I went ahead and then like I ordered this one, but this is actually the wrong connector. So now I'm going to go back and I just submitted another order to Arden about this, and I'm just going to keep this one around just because I actually need it for something else. But like, yeah, I make mistakes too. This is probably going to cost me to wait until like, I don't know, sometime later this week. So until I can test the sensor out, but it's okay. We all make mistakes and we all goof up. Part of the process.
You know, is that pressure sensor waterproof? Like the sensing part should be.
Yeah. Why?
You could like go to like hardware store and you can find the thread to put it in there and just get a tube and then fill it with water and you'll have pressure.
True. Now you see, that's a smart idea. Now I didn't think about that. Maybe you can actually.
Wait,
Yeah, you could.
Irma, one question though.
Yeah.
We have to count that measures the relative atmospheric pressure, right?
Yeah,
Yes.
PSIG.
Yeah, PSIG.
So, when we're in a vacuum,
Yep.
we have to subtract that calibration, or
You don't, because this is measuring the brake lines. The brake
Oh,
lines are under
from
pressure.
one point to the other point.
Exactly. What you'll have to account for is like the plus minus. For example, the brake lines are going to be around like 1,000 psi from the main reservoir. So, like I don't know, you have to add a certain amount, whatever atmospheric psi it is, because this is going to be offsetting it by that much.
Yeah, that's what. You mean
Yeah.
adding or subtracting that?
I think you'd have to add it because let's say like atmospheric pressure is like 10 psi and the brake line is 30, then it only say 20 psi because it's above atmospheric.
Yeah.
So you'd have to add 10 more.
Okay, I see what you're saying.
But it's not like calibrated to atmospheric. It's calibrated to whatever like the atmosphere it is in.
Correct.
So
then in that case,
like,
you wouldn't need to do that.
Yeah.
then yeah, you'd need to put in whatever vacuum pressure that you're in. Well, the
Well,
way
it's
you
in
do
a
the
vacuum.
calculation is
Wait.
like
is
actually
it,
yeah, it would that is true.
Yeah.
It would cancel out.
But for the European Hyperloop competition, it wouldn't, because that's not in a vacuum.
Okay.
That's on land, like within like open air.
Okay. That
So,
raises some other issues though in terms of the mechanical aerodynamic design of the shell, because that was designed for a vacuum in the beginning.
well,
it's
you're
okay.
not gonna reach the maximum speed of it anyway. It's a small test track.
Yeah, like air resistance,
Yeah. Yeah.
negligible.
The G is 10.
Yeah.
So
Okay.
okay, so I guess I'll show something that like if I had just put a bit of more time into this design, I would have gotten done faster and I wouldn't have wasted, like I spent a long time working on something that was never gonna work. Can I share my screen? So this is, I guess, a little bit of context. The way that the high voltage battery works is that there needs to be some sort of switch to control when the battery is connected to the load, when it's not, and how you're gonna, and then so you have to think, okay, the switch needs to handle the same current that's going through it and that same potential difference. So it's operating at about like maximum 80 amps continuous and 30 volts. And so one of the ways that we aim to solve this was to use a MOSFET and this bridge rectifier array that would allow you to control it. And you got to remember, even though the battery it works, it's a DC power source, it is a common port. So the same port that you use to charge it is the same port you use to discharge it. And so this switch needs to work in actually both of those environments and kind of act as a bidirectional switch. The current needs to be able to like flow in both directions. And the switch has to be able to control that current flow in both directions. This is like a switch realization that I did with help from Orist again. And I spent a long time. I was like, okay, I have this design now. Well, I need to buy the parts. I need to find parts that actually work. And all these so I spent a long time looking for diodes that would fulfill these specifications to build this bridge, or even just like, packages that already had them in this array. And they were very expensive, or they didn't exist at all. The diodes that would like fulfill what I needed either didn't exist or cost $100. So, and I spent like, a month working on this. And then I read the other day, literally last week, a design that is like an alternative bidirectional switch design that uses more MOSFETs. It uses a few more components, but these MOSFETs actually exist. So actually this would have required a MOSFET, but it wasn't out of the ordinary. Like, it was pretty common power MOSFET that you could buy. Like, it wasn't too expensive at all. They existed. The diodes didn't. But you could buy these, it's using the same ones, and then like make this switch. And all these components, I could find them like almost immediately. I didn't have to go searching on DigiKey or whatever to find them. So yeah. So if I had just done a little bit more research instead of just diving deep into one design, I would have, 1 month of work became a week.
It's okay. It's all about growing and realizing that like you can become a little bit better every day.
There was a good lesson though. That just comes like straight from like ESP1. You remember those like solution driven, like we have to be solution independent in our thinking. So yeah, that's important.
Yeah. I guess last thing is, since I'm gonna be stepping away a little bit from energy systems, June is here and I'd like him to like give some words, I guess, to you guys. I don't know why it doesn't let me add him to the leads all, but June, if you want to say something.
Sure. Yeah. So yeah, I'm gonna be leading the energy systems teams now that Kiki's taking over all electrical. Really looking forward to working with you guys on a more integrated level. And as always, we're gonna keep things going strong, and hopefully by the end of this season, we'll have a super fast functioning and robust pod. So yeah.
If it's any motivation, June actually converted a gas car into a electric car. I thought that was really cool.
Yeah, it's still a work in progress. We recently bought a more powerful motor. So before we were only working with 3 horsepower, and it still moved because it had tons of torque. But now we got a 30 kilowatt peak, 12 kilowatt continuous. So it's still kind of underpowered, but definitely more powerful than 3 horsepower. So that's gonna be fun.
What car did you convert?
2009 Kia Rio with a 5-speed manual, so you can still slam on the gears and have some great fun driving the car. So.
Wait, so this is a manual electric car?
Yeah, it's gonna be sick. You can go, so basically if we were to put the motor in reverse, we would have 5 reverse speeds, which is, yeah.
You can hit max speed going in reverse.
Exactly. 80 kilometers in reverse.
It's like a stunt car or something.
Yeah, yeah. It's it can be both front wheel drive and rear wheel drive.
All right, yeah. We're already like 20 minutes over. This meeting should be. Really appreciate all of you guys coming out today, and I hope that we're going strong moving forward. And we can keep up this kind of pace that we have going now. Seeing the work from all the sub teams, it's really really interesting to see. It's really motivating to see the progress that we've made.
Okay, guys. I'll talk to you next week then.
All right, see you.
Yeah, good luck, guys.
Bye.
Take care, guys. Bye.
Bye, everyone.
Thank you. Bye-bye.
Bye.